Dear student, myself S.S. Kamre presenting the e-contents on subject Basic Electrical and Electronics Engineering. This is our lecture number 2. We cover the topic resistors, its specification and color coding. Resistor is a passive electronic component which provides opposition to the flow of current. The value of resistor is called as resistance. Resistance of a material is defined as opposition to the flow of current. When the resistor is manufactured from material which has the high resistivity and low conductivity, such resistor has less amount of current carrying capability. When the resistor is manufactured from material which has low resistivity and high conductivity, such resistor has high amount of current carrying capacity. The unit of resistor is ohm. There are two types of resistor, fixed resistor and variable resistor, and hence symbol shown here for the fixed resistor and variable resistor. Resistors are mainly classified into two types, linear resistor and non-linear resistor. Linear resistor is that resistor in which the voltage is applied and current increases linearly with increasing applied voltage. Linear resistor is again of two types, fixed resistor and variable resistor. Fixed resistor has two terminals and whose value remains to be fixed. The fixed resistors are further classified into carbon composition resistor, thin film resistor, thick film resistor, wire wound resistor. Variable resistor. Variable resistor has three terminals. This variable resistor has notch or shaft is to be provided. Whenever we change the position of the notch, there is change in the value of resistance. Variable resistor is further classified into the three types, wire wound resistor, potentiometer, trimmer. Non-linear resistor. Non-linear resistor is that resistor when voltage is applied, current cannot increase linearly with the increase in applied voltage. Non-linear resistor is further classified as thermistor, light dependent resistor, photoresistor and varistor. Specifications of resistor. Whenever the one select the resistor for specific circuit or specific application, that user must know the specification. The first specification, that is the maximum voltage rating. This specification indicates that how much maximum value of the voltage is applied to the resistor. If the applied voltage is more than its rating, then that resistor may be burned out, and hence the user must know the maximum voltage applied to the resistor. Maximum voltage rating depends on physical shape and resistance value of resistor. Second specification, power rating. Power rating is the wattage of the resistor and is defined as the product of voltage and current flowing through the resistor. Whenever the current flow through the resistor, heat is to be generated in the resistor. Thus, the resistor has maximum dissipation rating set by the manufacturer, above which resistor will be burned out. Power rating for the resistor is given by 1/8 watt, 1/4 watt, 1/2 watt, 1 watt, 2 watt. These ratings are used for low power application, and for high power application, resistor have higher power rating more than 100 watt. Size of the resistor directly depends on its power rating. Next specification is temperature coefficient of resistor. It is also possible that when there is a change in temperature, resistance of the resistor is also changed. Hence, the temperature coefficient plays an important role whenever you select the resistor. Temperature coefficient of resistor is defined as ratio of change in resistance to the original defined value of resistance for the change in temperature. Temperature coefficient of resistor is expressed as parts per million per degree Celsius, that is ppm per degree centigrade. The next specification is the tolerance. Tolerance is the change or deviation from the nominal value of resistance in percent. Tolerance may range from 0.001 to plus minus 20%. Different types of resistor made of different types of material may have different value of tolerance. Operating temperature. This is defined as maximum recommended surface temperature at which resistor can operate effectively without damage. This maximum temperature is obtained as a working temperature produced by power dissipation inside the resistor and ambient temperature at which resistor is operating. Ohmic range. Ohmic range is the range of values from minimum to maximum resistance value that can be manufactured, and hence the ohmic range for the resistor is vary from ohm to several mega ohms. Color coding of resistor. Color coding of resistor is helpful to find out the value of resistor. When the resistor has several color bands present on its body, it is easy to find out the value from the bands present on the resistors. This band even specify the tolerance. The number of color band is present on the resistor body, and hence to remember the sequence of the color band, the students have to remember the one statement, that is B.B. Roy of Great Britain has a very good wife. The every capital letter with underline indicates the color. The sequence of the color, that is the first B stands for the black, then brown, red, orange, yellow, green, blue, violet, grey, white. All these colors have the specific value is to be assigned. This value is also range from 0 to 9. If this color is used at the specific band and it indicates the multiplier, it is always taken as a 10 to the power number of that color. If this color is used to indicate the tolerance, then the tolerance is assigned in the fourth column, that is to be taken as a change in the value of resistor. When the resistor has three color bands, how the value of that resistor is find out here. The first color band indicates the first significant digit, which is always taken from the left side of the resistor. The second band indicates the second significant digit. Third band indicates the multiplier, and when the resistor has only three bands, its tolerance is always plus minus 20%. We just see one example. For example, if the resistor has three color bands, yellow, violet and red from the left side. For the yellow color, the number is the 4, which is the first significant digit. Violet is the second color, indicates the second significant digit, and the value assigned to the violet color is 7, and hence I write here the 7. Third color indicates the multiplier, and hence the number or value assigned to this color is always taken as a 10 to the power of that number, and hence number for the red color is 2, and hence I multiplied the first and second significant digit by 10 to the power 2. As this register has only 3 color band, its tolerance is always plus minus 20%. It means that the value of register can be increased by plus 20% or decreased by minus 20%. The value of the register can be written as 47 into 10 to the power 2 plus minus 20% ohm. If we convert this resistance value in standard unit, it becomes to be 4.7 kilo ohm plus minus 20%. Sometimes the resistor have 4 color band, and this 4 color band is the most common representation in resistors. These bands always starts from left side towards the right side. The first two color bands is used to indicate the first and second significant digit of resistance. The third band is used to indicate the multiplier. The fourth band is used to indicate the tolerance. There is always some significant gap between the third and fourth band. So the multiplier and tolerance is always to be represented by some gap. This gap helps in resolving the reading direction. We just see the one diagram for the 4 color band. The first color band indicates the first digit, second color band indicates the second digit, third color band indicates the multiplier, fourth color band is the tolerance. And for this color band, we just find the value of the register. The first color band is the green, and hence for the green color number 5 is to be assigned, and hence the first significant digit is 5. Second color band is black, number assigned to the black color is 0, and hence I write here the second significant digit. Third color band is the multiplier, which is red here, and hence this multiplier is always taken as a 10 to the power of the number assigned to that color, and hence for the red the number assigned is 2, and hence I just take the multiplier as a 10 to the power 2. The fourth color band is the brown, and for the brown color the tolerance is plus minus 2%, and hence its value becomes to be 50 into 10 to the power 2 plus minus 2%, and if we convert this value into the standard unit, its value becomes to be 5 kilo ohm plus minus 2%. When the resistor has 5 color bands, how we find out to be value? When the resistor has 5 color band, the first 3 color band indicates the first 3 significant digit, and the fourth color band is the multiplier, and the fifth color band is the tolerance. So we just see the example for the 5 color band. For example, the resistor has 5 color bands such as blue, grey, black, red, gold. The first color band indicates the first digit. This color blue has the value assigned 6. The second color band indicates the second digit. This color has the value assigned 8. The third color band has the black. This is the third significant digit. The number assigned to the third color black is 0. Hence I write here the 0. Fourth color band is the multiplier, which is red. The number assigned to the red color is 2, and hence I write that number as a 10 to the power 2. The fourth color band is the gold, and hence it is a tolerance. It is always represented as a 5%, and hence the value of the resistor is 680 into 10 to the power 2 ohm plus minus 5%. We can also do reversing, means from the value of the resistor it is possible to find out the color code. If the value of the resistor is given, that is the 350 ohm plus minus 5%. First, this value of the resistor is converted in standard format such as first and second digit, then the multiplier and the tolerance, and hence this 350 ohm is converted into the standard format, that is the 35, indicates the first and second significant digit. Third is the multiplier, that is the 0, here that is the 10 to the power 1. Fourth is the tolerance plus minus 5%, and hence I indicate the color for that plus minus 5%. For the first digit 3, the value is to be, color assigned to this value is orange. For the second color band, second significant digit value assigned is green, and for the third value, the 1, the number or color assigned is brown, and hence the sequence of color becomes to be orange, green, brown, and for plus minus 5% tolerance is indicated by the color gold. Resistance value is also found out by means of character. Sometimes in the value of the resistor E, K and M, such letters are to be present. The E means ohm, K means kilo ohm and M means the mega ohm. The value of the resistor is indicated maybe in ohm, kilo ohm or mega ohm, and specific alphabet is to be assigned. In such case, the alphabet is replaced by the decimal point, and for E, K or M we have to given the unit simply ohm, kilo ohm or mega ohm respectively. And hence I take here one example, 33E4. Then the equivalent value of the resistor is 33.4 ohm. Here the alphabet E is replaced by the decimal point, and E means ohm, and value of the resistor is 33.4. The second 47K9. Again here the second alphabet K is replaced by the decimal point, and I convert this value into the resistance value, that is 47.9 kilo ohm. The third resistor example, that is the 10M5. Here again I replace the M by the decimal point here and gives the value of resistor 10.5 mega ohm. These resistors are used in most of the applications. That is the general application of resistor. Almost every electronic circuit is used the resistor to limit the current flowing through the electronic circuits. The most common application of resistor is potential divider, biasing circuit of transistor, amplifier circuit, DC power supply, voltage regulator, medical instruments, radio and TV receiver. The frequently asked question on this topic is define resistor, list types of fixed resistor, state specification of resistor, find the value of resistor from the given color code, find the color code from the value of resistor, state the application of resistor. Thank you, and if you understood all the content in this video, please like my video and subscribe my channel.